Hopefully you can see module 2. So the terminology. Um, there are few elements of the terminology that I would like to cover today with you. And some of them, yeah, I think I really want them to stick with you. I will start with the FAIR principles. Uh, FAIR is an acronym for findable, accessible, interoperable, and reusable. And these principles apply to any research outputs, but perhaps it will be the easiest if I describe them a little bit more using data as an example. And in fact, FAIR data or the FAIR principles originated when researchers were talking about the openness of the data. So when you think about your data sets or the data sets you interact with, you work with, findable. So the ability to find these data sets, think about the situations when you're trying to, the data sets exist or some type of data sets you want to access. Yeah, way to find them. So that's the F. Accessible. Okay, you know where they are. So you found them, but can you access them? Is there a particular login? Perhaps it's not just an easy login to create. Perhaps you have to get some credentials. Perhaps you have to get some permissions. So that accessibility. And then interoperability. So you know where the data set is, you manage to access it, but the software that you have, and that might be the standard software that everybody in your domain uses, does not want to read that data set. So that data set is not interoperable. So somebody who created it did not think about that interoperability. And reusable. So is there, for example, this may mean, is there permission to reuse that data? So do you know if you can reuse it? We will talk a little bit more about that in licensing. The fact that you could find a data set and access it, download it, and open it does not necessarily mean that it can be reused. So reusability can mean several things. For example, do you have the right to reuse it? So that's the FAIR principles. And FAIR principles can not only relate to data, they can relate to software, a report, that might be some other outputs, around the data that you have. Fairness is important in open science. What is also related or extends these FAIR principles are CARE principles, which are essential for research outputs when it comes to data sovereignty, indigenous ownership of the data. And CARE stands for collective benefit, authority to control, responsibility, and ethics. And these CARE principles, they are slightly explained slightly differently than FAIR principles. So the way data or other research outputs or research conducted, is it a collective benefit? Is it benefiting all people and groups involved? That doesn't only mean researchers, but perhaps people who are, they're part of their information is part of the data, or where I can probably give a little bit better examples based on my work in New Zealand. There is quite a lot of data and collaborative research in New Zealand that is related to native New Zealand plants, native animals, landscapes, and this is considered owned culturally by Maori people, who are the indigenous people of New Zealand. The Maori also have the concept of what they call taonga. So these are, we could translate it as sacred, for example, sacred native species of plants or animals. Now, on one hand, science wants to study them, the kind of traditional science, but that collective benefit has to include the interests of Maori people around the taonga species. Authority to control, that is quite self-explanatory. So that principle means that the stakeholders, and in my example, I'm giving Maori people, Maori tribes, or iwi. In Maori language, the tribe is in iwi. They have the authority over those elements of research. Not only the data, they also have the authority to say how the research might be conducted, if this is related to things that they have interest in. Responsibility, that obviously pertains to a lot to the researchers themselves, to have responsible behavior towards the work that they're doing and everybody involved, and the ethics. So this is very wide. It's not just the ethics of getting the approval from ethics committee to work with human subjects. This is a very wide question. So care principles are complementary to FAIR principles. And in open science, both of these groups of principles really kind of give the basis of open science. I'm going to change the tack a little bit, and I'm going to talk about persistent identifiers, another sort of terminology or terms or concepts. Now, persistent identifiers, again, a little self-explanatory. So it's the identifiers that can be assigned to either an object, we have digital object identifiers, or a person, a researcher, ORCIDs, or research organization registry, so organizations, to identify uniquely object. It can be data, paper, report, workflow, or a researcher or an organization that helps with those filling in those principles of findability, accessibility. We will talk a little bit more about some of these identifiers. Now, here regarding citing data and metadata. So this example, and this is a fantastic slide that Anelda created. This is an example. This is a paper. This is a data set that is published on the Zenodo platform. We will talk a little bit about Zenodo too. But the Zenodo platform is a repository where you can deposit your data set, your papers, reports, workflows. This is a data set. Now, look at all these circled elements. These are elements of metadata that are related to this data set. So metadata is data about data. We have the date published, when this data set was published, what's its title, who are the authors, and as you can see, Anelda also circled this green little dot. This is the logo of the ORCID ID. So there are two authors of this data set listed, and they both have created their own ORCIDs. So you can create your own ORCIDs for free. We will cover that too. And they connected their ORCIDs to this in here in this entry. So that means that if you look at a person, such as, for example, the first one, he's Andrew Kendall. If you look at his ORCID record, this data set will be listed there. So it kind of helps to connect information. There are things like the version of this data set. Here on the right-hand side, on the details, you have DOI, Digital Object Identifier. So that's the unique identifier I just mentioned earlier. This translates into if you use it in a DOI kind of interpreter, which is just a small website, it should point you to exactly where this data set is published and uniquely identifies this data set. There is, of course, files. So we have a lot of information about the data and the files, the data itself on the left-hand side, you can see it. And a really, really important stuff at the bottom on the right-hand side, license. So that pertains to reusability. So we have those FAIR principles. So this is metadata, those elements. And metadata and the way this was published, it is FAIR. we can find it. It is on Zenodo, which is a public repository. It is accessible on the left-hand side. You can download those files. These are comma-separated value files. There is a way to download it. It's interoperable, hopefully. These are comma-separated value files, so they should open. I can see that these are HDPI. Hopefully they're formatted correctly. Interoperable and reusable. We have the right kind of license. Now, when it comes to key principles, we don't have much information. Perhaps there would be more information we read through the abstract here. We don't have much information here in the screenshot. But as I explained, the CARE principles are sort of extension to the FAIR principles, and also, they kind of require a little bit to learn whether a data set or research paper or workflow kind of require a little bit more dive into the detail to see how these principles are fulfilled. Now, another term, and we're going to talk about more, open access. You have probably interacted and encountered open access several times. So you want to access a paper, you want to read a paper, and it might have been cited somewhere. And so you find a link and you get to the publisher website. And sometimes you can just get the PDF, it's available, you just do one click and you can read the paper. This is almost certainly open access paper. However, it's still quite common. You cannot access the paper, you have to pay, or your organization pays. That's something that might be invisible. So you go, oh, you need to log in with your organization. You have a login to university, Cape Town University, you log in. Oh, I can access the paper. Yes, however, that likely means if you had to use these logins to avoid paying, that your organization, your university or research organization pays pretty hefty fees for access to these journals. So when you're publishing in journals that are not open access, in order for other researchers to read your paper, they have to either pay for individual papers, which often you see these prices, which are ridiculous, $20 just for access, $40 to download a paper, and even more to get the full issue of the journal. And if you log in through your organization, that means the organization is paying a subscription, so annual, really high fees. Open access kind of flips it on its head. So the access to the journals is free for everyone, regardless whether they're a researcher and have a login. They can freely access any publication. When now there are different types of open access public publishers. It might be that we'll talk about this. It might be that there might be some payment involved from the researchers who publish, and usually universities and research organizations have the budget for that. Nevertheless, open access is also something that is inherently connected with open science. And we already talked about metadata a bit more. I showed that awesome slide with data about data. And metadata can have different elements. It can be very comprehensive. The more information about the data or your paper, your workflow you provide, the better. Now, the format of the metadata, there might be different formats. Sometimes it may simply be a small text file. So you might have data in a comma-separated value file, so table, columns and rows. And to keep it clean, not to keep adding information into the file so that it still is readable by some piece of software, you may have to have additional small text file with the metadata related to it. So some domains have very structured metadata, so how metadata should be provided. In some domains, it's not very well defined. And so that is up to the researcher, but any metadata is better generally than no metadata. Now, a little bit more on data sovereignty. I did mention data sovereignty ties very closely together to the care principles. And it is mostly related to data, obviously can relate to other research elements, is the ownership of the data by the indigenous population, by those populations that often, unfortunately, in the past have been ignored, or just, decisions were made against them in science. Now, in open science, these stakeholders, the indigenous people, are equal partners when it comes to research that involves anything that they have stake in, they have interest in. And it is down to the indigenous people. It is their governance of what they decide is the data that they want to have authority over. So finally, are there any questions that raised during my presentation?